Hello everyone, this is Michael. So I'm actually aware that some of you felt that the CSWA workshop conducted previously, the pace is a little bit fast, and some of you were unable to keep up with the workshop lectures. And I also noted that because of the time constraint, there are some small details I actually missed out during the lesson. So I decided to record some videos covering some of the part modelings and assemblies. Yeah, some of the models are already addressed, are already taught during the workshop, but I'll also introduce some new models in this video series. So this video is for those who wish to revise for CSWA for their retest in the future, as well as the students who intend to take CSWP or this kind of advanced courses. You can use this video as a revision to recap on your prior knowledges. So we will start with basic part 1, which is shown in this image over here. This was actually taught or already taught during the lesson. So let's start. I will skip some of those very fundamental knowledge about SolidWorks, such as how to change the angle, how to like rotate objects around, this kind of thing. Yeah, how to rotate your view, this kind of thing. Yeah, please refer to the prior recordings or refer to other online sources. I will dive directly into the part modeling. So first step, we create a part and we save it. Saving a file is a very good habit. Let's say, okay, I'll save it as basic part 1. Saving a file is a very good habit. I noticed that some of you tends to forget to save a file. So because SolidWorks is a very complex software, so sometimes it might crash. If it crashes and you didn't save it, it means whatever you've done are lost. So usually what I recommend is create the save file the moment you create this new part, and just click on Ctrl S while you are modeling this part. So first step, we need to create this this portion as a sketch. Then we extrude it across. But before that, we notice that there are 3 variables in this model: A, B, and C. So, and these 3 variables are given, the dimension of these 3 variables are given below, 110, 60, and 50. So it's possible to input these variables. It's possible to define this as explicit dimension, and it's also possible to define this as variables. In CSWA, it's actually possible to do either way. But in CSWP, as well as other higher tier or like more advanced CAD situations, it's usually more advisable to define it as variables, because you can make quick changes if necessary. I'll demo it later. So if we wish to define this as variables, the first step will be define this under the equation icon over here, which is this under the equation function, which is this sigma icon over here. If you don't see the sigma icon over here, or maybe you cannot find it, I'll explain over here. Basically, SolidWorks is a very customizable tool. So you can there's a lot of functions in SolidWorks, and you can customize them based on your own needs. For example, this is my current tab layout. You can see some of the buttons might be, for example, this flex over here. Yeah, some of the buttons, some of the buttons or icons I use in my tab might be slightly different from your layout. Yeah, this is because I customize this to my own needs. So how to do it is right click anywhere on this tab, go to customize, and I believe is shortcut bar. Yeah, and you can see a lot of buttons over here. All these buttons or all these icons represents set of function in SolidWorks. So if you don't see the sigma icon over here, just scroll down. Okay, let me see where is it. Okay, if you don't see it, you can actually search for it. Search for equation. Yeah, and this sigma icon is over here. So if you want to make this button appear in the interface, you can click your left mouse button, click and hold on this icon and drag it around. You can drag it here or drag it here, or basically drag anywhere you like. For example, you want to drag it here. And you can see this equation button has been put up to the tab or to the SolidWorks interface. If you wish to delete any of the button, for example, you don't want this equation button to appear here, you can just same as just now. Press and hold left mouse button and drag it anywhere drag it to like anywhere in the blank space where you see this red square with white cross, and release the left mouse button, and this icon is gone. You can use this method to customize your interface to fit the best of your need. Yeah. So let's go back to the topic. First of all, we need to define these three numbers, A, B, C, 110, 60, and 50. So click on this. Global variables. Since we want to define as variables, we use this global variable function. So first, we define A. Just type the letter A, then click on tab on your keyboard, and this open and close inverted comma should be automatically added by the system. If you know the basics of programming, you should know that this open and close inverted comma indicates that this is actually a string. So the name of the variable is a string, not a number. So if this open and close inverted comma is not automatically added, you can just manually type it. You can just manually type it using your keyboard. Yeah. So next, the value in this case is 110. So we just key in this number and click on tab again. Comment, if basically you can input anything over here. This is just for your own reference, because in the future, chances are in when you are doing those advanced parts in your CAD design, chances are you need to set a lot of global variables, and you might forget what each variable represents. So you can add some remarks in the comment section. In this case, we don't need to do anything because since there's only 3 variables, so we can just click on tab again. And after clicking tab, you can see this input box already automatically went to the second line, where you can define the second global variable. So like I said, usually if you type B and press tab, usually the open and close inverted comma denoting that it's a string will be automatically added. But let's say if it's not automatically added, you can just manually type it on your keyboard, type it like this, and press tab. Yeah, the effect is exactly the same. Yeah, the value is 60. After that, we define C, the value is 50. Okay, we define all 3 variables, and we can press OK. Next, we can cut out this shape. I don't know how to describe this shape. It's a Tetris shape, maybe. Yeah. So usually, in this case, I recommend drawing on the front plane because it will be in the same orientation as what is indicated in this in this image. So usually we will start with the origin so that the whole model, the whole sketch will not move around. Usually we will start in the origin, but feel free to start at any other location if you want to. So let's say we want to draw this shape. first step is just roughly sketch out the shapes. Yeah. Usually as you can see from the yellow line, these few yellow dotted lines, usually the vertical and horizontal relationships are automatically added. But if they are not added, you can manually define them by clicking on the line and click on horizontal or vertical. So let's define a dimension from this line to this line. The dimension is A. Like I said just now, you can directly input an explicit dimension of 110 is possible. But since we already defined a global variable, we can just define this as A. How to do it is under smart dimension, select the leftmost and the rightmost line. Click here. Instead of inputting 110, we input equal sign. We input an equal sign first. Then under global variables, when we input equal sign, there will be this pop-up box coming up where you can select different items. In this case, we will go to global variables and we select A. It's also possible to manually type in the letter A. Yeah, it's also possible. Then press OK. You can see that in this case, this dimension is being defined as 110, just like what was indicated in this image. But this image over here, A equals 110. But what's different? What's different from usual dimensioning is there is this red color sigma sign in front of the number. This denotes that this is a variable, or this is a function defined using equation. Yeah. So we can do the second one. The vertical height is B. So we do the same. It's also possible to directly type B, then press OK. Oh, okay. Okay, my mistake. When you are typing out a variable, you have to manually type the open and close inverted comma. Yeah, this to show that this is a string. So press OK. And you can see that this and you can see that we defined another variable. Just to clarify some of the doubts, I'm aware that some of you when defining it, although you inputted B but or A as like although you inputted a variable into the dimension, but you will still see a fixed number without this red color sigma sign in front. This is because because when you are inputting it, you are directly inputting in this variable without the equal sign in front. So if you don't have this equal sign, this variable will be automatically converted to a explicit constant. So if you wish to define it as a variable, you just need to add the equal sign in front of the letter and press OK. And you can see this red color sigma sign has appeared. So let's define the remaining. Let's define the remaining dimensions. This is 80. What else did I miss? If you're still seeing this kind of blue lines, means this sketch is not fully defined, and it's not fully defined. And if you're seeing this bracket negative in front of the name of the sketch, means it also means that this is not fully defined. Usually, this is not a good sign, except for some special cases. But usually, this is not a good sign. So what we want to achieve is all lines in the sketch should be black in color. Yeah, if it's black in color means it's fully defined, means it's good. Yeah. So if you don't know which variable, if you don't know which dimensions you are missing, what you can do is click and hold and drag some of the blue lines and see how they move. Yeah. So by seeing how they move, you will have a rough idea on which what are the dimensions you are missing. So in this case, we are missing a vertical dimension that constrains the vertical motion, as well as a horizontal dimension that constrains this horizontal motion. So let's see from the image, we know that okay, this dimension is 20. This is 20. And this vertical dimension is 30. 30. Okay. After saving everything, you can click on this exit sketch to save your sketch. Next step will be go to extrude boss base and extrude it across. You can use blind, but usually in this kind of cases, I will recommend using mid plane. Why I use mid plane is because if you use mid plane, um, the material will be extruded equally on both sides, and the front plane in this case where we draw the sketch will automatically be at the center of of this model, so that this front plane can be automatically used as a plane of symmetry for further uses if necessary. If we just do it blind, then we have to manually define a plane of symmetry using reference geometry. Yeah. So over here, we can see that we need to extrude for a distance of C. Yeah. So same as just now, uh, you can define it as 50 directly. And that's what intended, and press OK. But you can also define it as a variable, just like how you define it in a sketch just now. So we want to edit the depth of the extrude. So what we can do is use a single click using a left mouse button on this icon on the left of the name. Don't click on the name directly, because sometimes if single clicking or double clicking on the name, it will automatically ask you to rename. Yeah, like this. You automatically ask you to rename this feature, which is what we don't intend to do. So don't click on the name directly. Instead, click on this icon, and under this pop-up menu, we select this button, which is edit feature. So this allows you to edit how deep you want this to extrude. In this case, we want you to set it as a variable C. So same as just now, we just key in an equal sign, and under global variable we select C, which we have already defined just now. Press OK. Yep, and you can see this is the first stage of the model. Next we can carry out these extrudes, and we can carry out these extrudes. We want to extrude it downwards. Yeah, so we create a sketch on the top. Let's create a rectangle. We know that the distance away, the distance away from each side will be 10, and this dimension is same as here, is 20. So we define this as 20. Then after that, we can go to extrude cut, and this time we go to extrude through all. If you see that your sketch actually extruding in the opposite direction, all you need to do is click on this arrow sign over here, and the direction of extrusion will be changed. Yeah. So we want it to be extrude through all, then click OK. Next, we want to extrude cut away this portion over here. The dimension is 30 and 25. So we we draw a corner triangle in sketch. we use this vertex over here as a reference so that our rectangle can be fixed. So we know just now we know that this dimension is 30 and the distance away from the top edge is 25. Then we need to extrude cut. This time we don't want to cut through everything. Instead, we want the result of the cut to be in the same plane as this portion over here. So we will go to up to surface, and in this pink color box, we select this surface. Just left click on this surface to select it, then press OK. Yep, and we are done. Next, the last step is cut away this small hole at the bottom. So same as just now, we draw a rectangle. The dimension is 10 and 15 on each side. So okay. Before I continue, I want to address out a common mistake made by some of you. So basically is in SolidWorks, if you want to extrude a feature, usually it requires a closed sketch. Okay, for example, a triangle like this is definitely a closed sketch. A rectangle is also a closed sketch because they have an area. But let's say this is not a closed sketch. This is open because it's missing one of the sides. This is open, and technically these don't really have an area. So in SolidWorks, if you want to extrude or revolve or add some features to open to an open sketch, usually it will fail. Usually it will fail. Unless you draw it in a specific manner. But in this case, we just assume it will be failed. So for example, okay, let's remove all this. For example, in this case, I noted that some of you actually draw this rectangle something like this, and they went to extrude it directly, and of course it will fail. This is because this is actually an open sketch. Although it's a bit hard to see because the last side is coincide with this line over here, but this is still a closed sketch. Sorry, this is still an open sketch. So what you need to do is manually add this last side, and this will become a closed sketch, and you can extrude it and you can add feature to it. Yeah, and of course the easier way is just draw it using a rectangle. Rectangle always has 4 sides. So I'll continue. We just add the remaining 2 dimensions. 15 and 15. Save it. Extrude cut. True all. Okay, I believe that's it. Let me see. Oh, assign material. Yeah. So in actual exam, okay, basically when we are trying to validate a model, both volume and mass are possible methods to validate a model. But in exam, it's possible for them to ask volume, but in some of those advanced parts, it's actually more common for them to ask you for the mass. So in order for you to get the correct mass, they will you need to assign a material with a specific density to this model, and this material will be given in a question. So in this question, it's asked you to assign this material nylon to it. So how to assign a material is under the feature design tree. You can see here says material bracket not specified, means currently we don't have a material yet. So what you can do is right click, and you can see this. There are some of those like very common material, for example, ABS plastic, aluminum alloy, brass, copper. Yeah, this kind of like uh, uh, very common material already listed here. And of course, you can change this uh, by click on this manage favorites, but I won't really go to the details. Usually, we need to click on the first button, edit material, to go to the material table. SolidWorks have most of the industrial material built in, so you don't need to define anything by yourself. But in some of the very rare cases, not in the exam, definitely not in exam, but in the future, in some of the very, very rare cases, you might have to manually define a material, but I won't go into the details. Yeah, so under SolidWorks material, we want to find nylon, nylon 610. Nylon is a plastic, so we find it under plastic folder. So we can find it nylon 6/10, which is the material we want. You can see over here, all the material property has been defined. In this question, the most relevant material property is mass density, which is this value. 1400 kg per meter cube. Yeah, because we need this value, because SolidWorks need this value to evaluate the mass. So we select this, click on apply, and then close it. You can see now the material become nylon, and the the look of this model also changes slightly. It becomes slightly transparent. Yeah, this is because SolidWorks, those inbuilt material are trying to simulate the color or the texture of this material. Yeah, so we can assume that in real cases, nylon material will look somehow a bit similar to this. Yeah, grayish, translucent. Yeah. So after we define the material, we can go to mass properties. This is under evaluate. If you don't see this evaluate tab, same as just now, go to right click under customize or under toolbar or and under tabs, you can check this to make the evaluate appear. Yeah, so go to evaluate and click on mass property. And you can see this is the mass and this is the volume. Usually they will ask you for this value, either this value, and they will ask you for either this value or this value. But more commonly is this value. Okay. I believe that's all for basic part one. That's all.